There are 4 problems that do not involve a graph, and the first one is very straightforward. So write the equation of a polynomial with the following information. Again, this one's going to go very fast. I recommend you mute the video and try it on your own. You may not have enough room, and I'm writing kind of big, so I'm going to use a separate piece of paper for each of these. So f of x equals, let's see, I have no idea what the leading coefficient is. I know I have a root of 0. I know I have a 4. And I have 1/3. Whoa, 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 whoa. Okay, so if you have muted the video, I would say unmute it now, but you can't hear me say that. So I am not going to put x minus 1/3. What I am going to do is come over here on the side with some green, and I'm going to say that if x equaled 1/3, then I would go through a whole process to figure out what that factor is. It is not x minus 1/3. So what I'm going to do is multiply by 3, cancel, cancel, 3x equals 1, 3x minus 1 equals 0. We've seen this. That's it. 3x minus 1. Okay, back on track now. We can plug in the point -1, -3, crank out an a value. Let's go kind of quickly. So -3 equals a, -1, -1 plus 4, 3 times -1 minus 1, -3 equals a, -1, 3, -4, -3 equals, that's 12a, divided by 12, we get -1/4. Lucky us, final answer. Let's write it in whatever color you want, but I'm going to use red. F of x equals -1/4, whoops, squeeze an x in there, x plus 4, and 3x minus 1. Nowhere in this problem did they say that we have double roots, triple roots, none of that. We're not going to play with that on this problem. It does happen on the next one, though. So here goes. Next problem. Roots at x equals 3 with a multiplicity of 2, and x equals -2 with a multiplicity of 3, and has a y-intercept of -36. Whoa, okay. Because of sliding back and forth, I'm going to write just a couple things on the paper, and then we'll go from there. So for the second problem, we have x equals 3, multiplicity of 2. I just write it like that sometimes. If you want to do what we did on the previous problems and be like, oh, it's a double root, feel free, totally fine, same idea. X equals -2 with a multiplicity of 3, so triple root, and it has a y-intercept of -36. I'm going to write that like a coordinate. That's just good to know. So let's jump in. Same thing we've been doing. Don't make it harder than it is. F of x equals, I have no idea what comes in the front, x plus 3, but it's squared. Oops, I accidentally lied. X minus 3, but it's still squared. Sorry. And then x plus 2, but it's cubed. And we're going to use that to figure out that. I'll pause here, make sure we're good. Are we good? Well, you can't respond. It's a video, so let's keep moving. -36 equals a. Doing a lot in my head here. Plug in a 0. 0 goes here. -3 squared is 9. 2 cubed is 8. That gives me 72a is -36 divided by 72. Going very fast. -1/2, good to know. We'll talk later about the fact that it's negative and what that really does to the graph, although I think it flips it upside down, but the end behavior changes. But anyway, I'm getting ahead of myself. I love talking about polynomials. That's just what I like to do. It's a good way to have friends. Hey guys, who wants to talk about polynomials? Oh, he's here again. Okay, that was the second problem. We're going to go to the third problem now. Here we go. Things are about to get a little wacky, and the things I'm going to say are going to be very important for this problem and the next one. So I'm going to slow my pace down just a wee bit. We have roots at 0, square root of 5, and -6, and it passes through that point. I'm going to write that down. And then I'm going to make a huge point and write it on the paper and draw stars and arrows around it because it's super important. So just so I don't have to look back and forth, we have roots at x equals 0, square root of 5, -6, and it passes through the point 1, 4. Okay, All right, let's jump in. We are going to write, don't get too carried away, don't get too far ahead of me on this one, trust me. Because you don't know what could have affected the stretch and flipping of this. You don't know. AX. And then you're going to be tempted to put this. You are not wrong. You are exactly right. But there's more. Okay, and here's why. Here is why. A minute ago, we had a root, like an irrational root. Irrational meaning, if you took the square root of it, you would not get a number that can be expressed as the quotient, fraction, between two integers. See, good luck with that. Square root of 7 is irrational. Square root of 5 is irrational. Square root of 3 is irrational. Square root of 2 is irrational. Square root of 4 is not. Just say it, all right? There's the difference. All right, that conversation's over. This is an irrational root. And when we found the irrational root, it actually was a plus and a minus. Okay, let's come over here. When we found this, it's called a complex root. You can call it imaginary. Complex is another word that's used in a different context. But when you found this imaginary or complex root, it also came in pairs, plus and minus. There are very many questions I have seen in many years of teaching where they try to trip up teenagers with this idea. They did not tell you all the roots. They told you this one, and this one, but what they didn't tell you was this one. Irrational roots and complex roots come in pairs. So, there's another one, and it's this. I'm going to write all that down in just a minute on the actual notes. You'll see it in a second, but in the meantime, let's keep moving. X plus 6. We're going to plug in a 1 and a 4, but before we do, trust me, it is going to be so much easier if you're not having to be like 1 minus the square root of 5 and 1 plus the square root of 5 and then like, oh man, that just hurts. It just hurts. Trust me on this. AX, X plus 6. Okay, over here on the side, I'm going to do some work in green. You'll see what I'm doing. It's fun. X minus square root of 5, X plus square root of 5. X times X is X squared. X times square root of 5 is the square root of 5 times X. The X is not under the square root. Square root of 5 times X is, well, this one's negative. The square root of 5 times the square root of 5, ooh, that's the square root of 25. Okay. Oh, these cancel. Lucky us. So lucky for us. The square root of 25 is 5. That's what we get. So we can clean this up a little bit when we are given an irrational root by what I call foiling. A lot of people have called it that for centuries. You can also use the box method on this, and it looks a little sloppy, but it cleans up very nicely. Notice the square roots are gone. That is not a coincidence. In case you care, there's a word for this. These are called conjugates, binomials with opposite and middle terms, middle signs, I mean. It's a good way to clean things up. Okay, there it is. Now we will proceed. We're going to plug in a 4, plug in a 1. So 4 equals a times 1, and then 1 squared minus 5, and then 1 plus 6. Feel free to do a lot in your head. 4 equals a times negative 4 times 7. So 4 equals negative 28a. A equals negative 1/7. We're ready for a final answer. Oh man, forgot my X. I hate it when I do that. I'm going to go ahead and jump to this form. This was a little sloppy. I like this one better. X squared minus 5, and then X plus 6. Okay, the big idea we stated a minute ago, and I have room on my notes, and you may not have them on yours, but I'm going to squeeze mine in there. I'm going to squeeze it in right there. Well, not much squeezing to do on mine. But irrational roots and complex, and I'm going to put in parentheses, imaginary. I hate to use that word. Roots come in pairs whether they said so or not. So in parentheses again, I'm going to put plus or minus. Okay? Good to know. Keep that in mind. You see this, they left something out. You see this, they left something out. Let's move on. Okay, one more problem. I'm going to use a separate piece of paper for this next one. Just going to kill as many trees as I can. I'm really kidding, I don't. Okay, they gave us the roots, and they didn't tell us anything about multiplicity, so we're not going to let that be an issue. So f of x equals, okay, oh dear, already we have a problem. So over here on the side, we're going to say x equals negative 2/3. Well, if x equaled negative 2/3, we can multiply both sides by 3, and we'd have 3x equals negative 2, and we'd add 2, and we'd have 3x plus 2 equals 0. You can do all that in your head if you like, but I'm just showing you the process that would lead you there. So we have 3x plus 2. And now we're going to have x plus 3i. And we're also going to have, you know where this is going, x minus 3i. They come in pairs. They come in pairs. So on the notes themselves, I'm going to put plus or minus here. I'm going to put plus and minus here. They weren't written, but they're implied. Okay, has a leading coefficient of 1. You are tempted, as am I, to put a 1 right here. Don't. Why not? I'm glad you asked. Let's explore. Let's clean some things up a little bit, actually, and this is not always necessary, but it's good to know. If we multiplied all these out, and I think we can do that within this. By the way, let's put an A right here. Forgot that. Sorry. X squared minus 3ix, looks like Roman numerals, it's not, plus 3ix minus 9i squared. Okay, we are dabbling with imaginary numbers, but they won't hurt us. They do exist. I'm not a conspiracy theorist when it comes to imaginary numbers, or anything for that matter. Cancel those. And we have a little bit of stuff to work with here. I'm going to go ahead and tell you what it is, because, well, let's do it. If I had negative 9 times I squared, well, negative 9 times, well, I is the square root of negative 1 squared. Okay, I is the square root of negative 1, just good to know. I is square root of negative 1. But if I square it, then I have lifted the radical off, so I have negative 9 times negative 1, which gives me 9. So what I really have here is plus 9. Okay? All right, I'm going to keep going. Mr. Reader, you haven't had to keep going before. Why don't you just plug in a 1 and plug in a 1 where? They didn't give you a coordinate, right? No, they didn't. Here's what I'm going to do. Let's keep simplifying this. A. 3x cubed. Let's go this order. 2x squared. 27x 18. Okay. I want this to have a leading coefficient of 1. Check this out. One more step. This is a little bit confusing. This is the only time I've ever explained it this way, but 3ax cubed plus 2ax squared plus 27ax plus 18a. Why did I do all that? It looks complicated. I hear ya. This is my leading coefficient. And I want it to equal 1. But it doesn't. So let's make it. If 3a equaled 1, what would a be? 1/3. All of a sudden, everything is going to come into focus here. We can write this answer multiple ways. Here's my final answer. I will put this one in blue for a change. And I'll put it over here on the side. Final answer is, I'm going to go back to this one. 1/3, 3x plus 2, x squared plus 9. I could also instead write my answer by putting a 1/3 in for every a, which I can also do here. 3 times 1/3, that would be 1 x cubed. I don't know why I shouted that. 1! And then 2 times a third, that's 2/3, x squared. 27 times a third, that'd be 9x. And 18 times a third, that would be 6. Either of these are perfectly acceptable. There are others as well. But there's your 1 staring you in the face. And then here's another 1 staring you in the face. And there's a 1 right here.